Okay, I have just a tiny bit more to show you. This is chapter 1, lesson 2, just the very end of it. There's just a little bit left to show you, but we kind of like to keep these videos a manageable length, so this will be our third video. This will be short and to the point. Okay, when you measure an angle in a circle, there's 360 degrees. So when you rotate, if somebody would happen to rotate around more than once, and rotate around several times, you could keep adding on 360s and 360s and 360s. But if all you were concerned about was the size of the angle from where you started to where you ended, then you really don't need to give an answer bigger than 360s. You can always give something between 0, I guess really 359.999, or we could say really between 0 and 360. But there's no need to give an answer bigger than 360. Well, there's no need to give a negative angle. If you measure a negative angle, you started in the positive x-axis and you went backwards, but somebody could have come around the other way and met you over there, and you'd end up in the same place. So what's going to happen sometimes is they'll give you angle measures that are too big or too small, and they'll want you to give the angle that's the same angle that's between 0 and 360. So example, here's 425 degrees, meaning somebody started in the positive x-axis, they rotated around 360 degrees and kept going. So the question is, what's an equivalent angle? What's the smallest positive measure that would get you to the same place? And the answer is, if the answer is bigger than 360, just take off 360s. So I'll take off 360, and when I do that, I'm left with 65 degrees. So if I rotate 425 degrees, I end up in the same spot as if I had just rotated 65 degrees. Okay, so if an answer is bigger than 360, what do? You take off 360. If an answer is less than 0, what do? Well, then you add on 360s. So here I have a negative 73, so this person had some angle, they backed up 73 degrees. Well, if I add on 360, I've got a positive, I got a negative, I know I subtract those, and I'm looking at a positive 200, and it looks like an 87 if I add that up. So instead of backing up 73 degrees, it'd be equivalent to me going in our standard direction, 287 degrees. Okay, what do you do if they give you 127 degrees? Well, look, it's already between 0 and 360. You're done. That's your answer. So don't get fooled by something like that. So any angle, if they give you bigger than 360, you can give an equivalent angle between 0 and 360. Any angle less than 0, you can give an equivalent angle between 0 and 360. All right, very last question, kind of a factor label question if you've had chemistry. Same kind of idea as factor label. But just to get used to something like this, a propeller rotates 1,000 times in a minute. How many degrees will it rotate in 1 second? Okay, so start with what we're giving. We have 1,000 in its rotations, and it does that per 1 minute. They want us to convert, and they'd like us to convert it to degrees in seconds. So if you remember, if you've had chemistry as factor label, and there's two things I need to convert. I need to convert a rotation to a degree. I need to convert a minute to a second. So let's do the easy one first. I know there are 60 seconds. This is the time seconds now. 60 seconds in 1 minute. I'll just use the same notation anyway. 60 seconds in a minute. So I'm going to write that as my factor label. I want the minutes up here, so then I can cancel that out with the minutes down there. So I write there's 1 minute is the same as 60 seconds. So I use that part of the factor label. Next thing I want to do is I need to convert these rotations to degrees. And we did that at the very beginning, the very first slide tonight. We said a rotation, well, it's nighttime when I'm recording this, a rotation is 360 degrees. So one rotation, very first slide, was 360 degrees. And again, I want to cancel out the rotations that are here. So when I multiply this, I have to put the rotations down here, one rotation. So up here goes the 360 degrees. And let's see if this works out correctly. I've already canceled out my minutes. Let's just do that again. The minutes are gone. Oh, look at that. The rotations are gone. And what am I left with? I'm left with right here, degrees per second, which is what they want. I've written all over it now, but they wanted degrees per second. Let's multiply, and you know with fractions you can cross cancel. So the 60 and the 360 divided by 60 gives me a 1 and a 6. Fractions, I'll multiply the tops. Looks like 1,000 times 1 times 6. Looks like 6,000. My units there are degrees. And the bottom I've got a 1 and a 1 and a 1. And my units here are seconds. So it's going to rotate 6,000 degrees every second, completing the problem. All right, that completes Chapter 1, Lesson 2. And there'll be lots of homework that's just like these problems.